So I wanted to welcome you guys all to Devmonth and Wrangle's React Focus Night. I'm your host, Avery Francis, and I'm Senior Talent Manager with Rangle. Thank you very much for coming to this awesome space tonight, and I know it's beautiful outside, so we appreciate it that much more. We are a leading JavaScript consultancy here in Toronto. We're actually located conveniently just up the street. Tonight's event is all about the JavaScript superpower. So we have two special speakers tonight who both work with Rangle. We have Seth Davenport and Abdella Ali. I want to just introduce you quickly to Seth Davenport. He is one of our speakers tonight, and he's a senior software developer senior software developer that's been working since 2004. And he also is a technical lead within Rangle, and also an all-around great guy. And he's heavily involved in all of our interviews, which is pretty interesting as well. And then we also have Abdella speaking with us tonight as well. He's a senior JavaScript developer. And interestingly enough, he was Wrangle's first hire. So he has a lot of interesting information around how we grew as an organization from 2 to now 100. So thank you so much for the speakers that have come out tonight to join us. And let's just get into it. So I'd like to welcome Seth to the stage. Thank you.
So hello, everybody. I'm Seth. I'm a senior developer at Rangle, as Avery just mentioned. And I've been asked to come and talk to you guys about React and what we do, how we do it, what's our involvement with React at Rangle.io. So, as a consulting company, we start new projects on a very frequent basis. Every 2-3 weeks, we're starting a new project. And React has become a core element of our business. We started out with AngularJS primarily, but over the last year, our React practice has been growing. So we've completed around 10 React-based client projects in the last year. And we're starting to realize, or we realized a while ago, the React and Flux community is the main driver, I think, of interesting new architectural ideas in the JavaScript space right now. So we're very happy to start taking on that work. So a little bit about me. I've been writing code since the days of PHP 4. Not something I'm proud of, but I did it. I'm a member of what we call our support squad, which is basically a group of relatively senior developers, and we do kind of the DevOps stuff. We make sure that projects get started on the right foot with the tool chain. We kind of maintain our best practices, and we do a lot of internal and external developer training, and I'm the resident React fanboy. So as a consultancy, we have some specific challenges. Sales usually comes to me, like on a Friday, and it's basically like, this contract got signed. We need a team for like a 6-week project on Monday. Go, right? And in the past, we would spend a week on that project, a precious week, fussing around with tools. We can't afford to do that. We're also constantly onboarding new people. And while React is great, the ecosystem is so sort of decomposed into different libraries that it can be very difficult for newcomers to, get in and put together a coherent sort of code base with an architecture that has sound decisions at the beginning. And then, as a senior developer, I'm the guy who usually ends up fielding any issues or bug support requests after projects have ended. And I was seeing a huge variance of tool chains. And that made my life a lot harder. We also have very cross-functional teams. So, you'll have 2 developers on the team, and they're all gung-ho about React. And you'll have a designer who's like, what are these inline styles? What is this crap? I can't deal with it. So that's something that we have to factor in when we're putting together our tools. So none of this is to sort of be negative about React, but these are just sort of the real sort of constraints that we face. So I thought I'd talk a little bit about, how do we deal with this? How do we spread React knowledge across teams that are forming all the time, often with new hires? As you guys all know, the ecosystem is changing really fast, right? It's one thing to come up with a set of guidelines on GitHub, and it's quite another to actually make sure they're up to date and make sure that that updated knowledge actually makes it into new projects as they're starting up. So how do we spread that knowledge around? And then, of course, there was my original constraint, how do we save time on tooling at the start of each project? So, I mean, initially, we just said, all right, let's write a big old wiki with a whole bunch of architecture, coding, DevOps sort of best practices. And we'll keep it up to date, and we'll make sure that our developers all read it, and we'll take their feedback and we'll roll it in. That worked okay. It didn't work that great. The reality is it's easy to go and read some guideline or some style guide, and then sort of say, yeah, that makes sense, and then forget about it. The other thing with tooling and starting projects is it's the details that kill you, that waste your time. And it's very difficult to specify a good sort of toolchain approach, in English, right? You really need to program it. And we were still having teams building up their React setups every single project. And we were running around basically making sure that teams had unit tests, that they were doing continuous deployment, that they were using the correct one of about 14 different routing solutions in React. So I found that teams were, once they got going, they were very productive with React. But in that first week, we were solving the same problems over and over and over again, right? How do you minify and bundle your code for production? If you don't do that, performance is going to be terrible. It just is, right? How do you access APIs on other domains? A lot of junior developers come and they see a CORS error and how do I deal with this, right? And then they go on a backend and they put allow origin star, which is of course a huge security hole. And then I have to go and sort of breathe fire. And then there are projects, with 200 lines of code for gulp, just to bundle and minify stuff. When if you do Webpack properly, it's like a 10-line config file and you're done, right? And then there's, my perennial favorite, which is that every time I have to set up Karma, it is a pain in the butt. Karma is a unit testing solution. And then, of course, you do all that, and you're still faced with the React ecosystem, right? Nicely decomposed, lots of different options, but how do you know where to start? The whole JavaScript fatigue, right? Do I use ES6? Do I use ES5? Flow or TypeScript, right? Which bundling solution? Which state management solution? Which routing solution? How do I deal with CSS, which actually in React turns out to be a whole can of worms by itself? So, we were getting very, very tired of having all the projects sort of answer these questions slightly differently, and just no consistency, very hard to maintain. So really, I love React, I really do, but I just want my coders to be able to code, right? I don't want them to have to waste a week at the beginning of every project with all of this stuff. So what we ended up doing in our second attempt to solve this is we just came up with some standardized tech stacks. There's a small number of sample repos where the tool chain is all set up the way we've consensually agreed is the way we want to do it. The support team's job is to make sure that they're kept up to date. We have a simple little demo app in there that sets an example for people coming to the space so they can see what good, clean code looks like. And we also, make sure that all the developer tools that you get in the React ecosystem are working correctly, because they're pretty good when they work. We make sure that, production build tools are set up, right? We have a solution for actually serving it. We have minification, we have bundling. We make sure that the quality tools are set up, linting, unit testing, end-to-end testing. We make sure that the design tools or the CSS tool chain is set up so our designers don't have to worry about it. And of course, we're really big on continuous deployment. So we make sure that projects that are spun up are compatible with our deployment solutions. And that, developers now have no excuse for not deploying automatically on merge. And so this has a lot of benefits, right? Now, every time we start a new React project, it's the latest sort of iteration of what we feel is the correct architecture and toolchain. As I said, production and debug flows are ready to go. You don't have to waste time on it. I can, now when sales tells me we're starting this Monday, I get in at 10 to 10, and I spend 10 minutes setting up a repository and a continuous deployment pipeline, and it's done. That used to take me days. Now it takes me 10 minutes. And we also have a sample app. So if we have new hires on the team, it's an example of what good looks like, which is, in my opinion, huge. You can read all the material that you want, but at the end of the day, people learn by example, and you have to see something in action. And a side effect, like a bonus of this effort that's come up that I didn't expect, is that there is a little bit of work to maintain these stacks, but it's work that I can sit down with new hires about, and we'll go through it, and I get some work done, and they get some excellent training opportunities. And so after they've worked with me for a week or two on these things, generally speaking, they're ready to just be dropped on a project, and they know what to do. And that, to me, is really gratifying. So what does this have to do with React? Well, one of our stacks is our React stack, right? And it's open source. It's on our GitHub page. You can go and download it. You can play with it, or clone it, I should say. I also have a copy of the sample app actually running on Heroku. This took me about 5 minutes to set up this afternoon. It's probably going to take another 5 minutes to start up because Heroku's gone to sleep because I'm cheap and didn't pay for it. But this is our sample app, right? And it's very simple. Sort of the minimum functionality just kind of demos a form, and then the Redux counterexample that everybody's probably familiar with. So let's talk about this starter project. The architecture is React Redux. We've done Flux in the past. We sort of came to the conclusion that if you're doing Flux correctly, it ends up looking like Redux anyway, so you might as well just do that. And it can be served two ways. It can either be static bundled assets from Webpack that you just copy to an HTTP server, or we also give you like an example Node Express server in case you need to do something more sophisticated. Fairly standard React toolchain these days. Webpack, Babel, which allows you to transpile ES6. It can work with Node 4 or 5. So my goal is to support the latest long-term support version of Node. And then for our CSS toolchain, which I'll talk a little bit more about later, we're using essentially a CSS transpiler called CSS Next. Testing, we use the linter tools for both JavaScript and CSS. It's important to lint your CSS. We're using the usual suspects for testing, Karma, Mocha, Chai. For testing sort of component level DOM manipulations, we're using Enzyme from Airbnb. And then we also have in there a sample of some end-to-end tests based on Selenium, or a wrapper around Selenium called Robot.
And do you follow up with the developers to make sure that they're getting code coverage, or do you?
Yeah, we have bi-weekly external code reviews where somebody on another project will go and review for an hour. He'll just take an hour and just kind of go nuts in the code base looking at stuff.
Look at the diff and Git or whatever and see
Yep.
what's new and what about.
And one of the things to check for is coverage percentage and whether the tests make sense or whether they're just like creating a bunch of things and then not testing them in order to get coverage, right? Which I've seen. Yeah, deployment, as I said, you can use the bundled Node.js server, or you can just bundle everything to static assets and stick it on S3. We have a Node server that's there for you to use, which I've written some code to help you proxy to APIs without having to really think about it. So you don't have to do the CORS allow all. We throw in Helmet.js, which is a bunch of middlewares that close common sort of cross-site scripting holes. And logging and error handling, it's not obvious to a newcomer how to do that in Express. So we at least try to start you from a sane place there. Yeah, developer tools. If you run in production mode, npm start, they're all turned off like they should be. If you run in developer mode, npm run dev, we make sure that your hot reloading works. We make sure that your Redux dev tools work. So developer experience obviously helps us a lot in that area. So I can actually show some of those tools. So I've cloned and installed the starter here, and I'm just going to run it in dev mode. So it's the same app, but this time it's in dev mode. So that means, you know, my React dev tools are connected and working. All the components are nicely named. Because this is a Redux app, we can do all the clever Redux stuff. So we've got our actions being logged. So as I log in, wait a second. Let's see if I can turn that on. You know, and we actually use the Chrome extension version of the Redux DevTools, simply because it doesn't pollute the code base as much. And so this is actually really great. It's several of the different tools that they have just as a Chrome extension. And so you can do like really fun stuff. Like, for example, rewind your application. This right here is worth the price of admission for Redux, as far as I'm concerned. When I saw this, when I said Dan Abramov's talk last year on this, I was just like, okay, I'm done with Angular. This is how I'm doing it. Although interestingly, we are using Redux with Angular, so there you go. Yeah, so the only other stuff I kind of wanted to talk about with this was, if you go into our code, you'll see that our sample app, while simple, is set up, you know, according to our coding guidelines. You know, the folder structure is what you would expect. You know, most of the code is actually in stateless components, as you would expect in a React application. Very granular components, in fact, consistent with some of the ideas around atomic design. I'm trying to actually find you a good component. Like, and then all the sort of state management, the Redux stuff is handled in our containers, which are basically our single page level components, which are in their own folder. Right, and this is where all the Redux store map to props, map dispatch, map state to props. So there are a few quirks with what we've chosen to do, which I'll call out. The starter is not meant to be sort of a generic thing. It is a little bit tailored to our practice. And so I'll just step through some of those tailorings. The first one is CSS. One sort of somewhat controversial, I guess, idea in the React community is the concept of inline styles. People just put their CSS directly into the component. And they do that because it effectively scopes it to the component. And that's a good thing. It means if you're changing the style of a button, you're not going to break a form somewhere else. And it works because you're encouraged to keep your components really small. Now, in order to do this and handle stuff like vendor prefixing or media queries or some of the fancier stuff, there's a library called Radium, which has become very widespread, which basically sucks out those inline styles and transforms them, adds vendor prefixes, that type of stuff. We don't actually use it in these starters. There's nothing stopping you from using it in these starters, but we've actually opted for a different approach for a few reasons. Radium's great. But our designers don't like it very much. The reason for that, I guess, is that in order to really kind of do inline styles properly, it's not enough now just to know CSS. You really kind of need to know JavaScript and React. And it turns out that's a big ask on some of our cross-functional teams. You know, it'd be like asking me to be an expert in graphic design, which I'm completely not, as you can tell by my crappy-looking slides. So that's something, you know, we tried to work around. The other thing with Radium as well, it does do vendor prefixing. There's another solution out there called Auto-Prefixer, which I like a lot better. It pulls down data from caniuse.com and allows you to target specific browser versions. So it's much more robust. And the other nice thing about auto prefixer is it does the transformations at build time. Radium does them at runtime, which seems like a performance cost. I don't have numbers to prove that it's actually problematic. I'm probably just being paranoid, but it still seems like something I'd rather do at build time. On the other hand, if we just let our designers have free rein, we'd have a bunch of external style sheets linked into our HTML, which has other problems, right? There's no scoping. All your CSS is global. You adopt a lot of naming conventions to sort of handle that, block element modifier, that kind of stuff, which is fine, but why do it by convention if you can get a tool to automate it for you? So what if I told you that we can actually have the best of both worlds? So what we actually do is we use Webpack, which allows you to import CSS directly into your JavaScript, and it will go through some loaders that will transform it in various ways. And the transformer that we use is called PostCSS. What we do is we populate it with a bunch of plugins. The first one is called CSS Next. It allows you to write CSS4 variables and advanced syntax, and it will transpile it down to CSS3. Then we run it through a little thing called PostCSS Local Scope, which basically fiddles with your classes so that they are scoped to the component by magic. And then we run it through AutoPrefixer, which allows us to target IE8 should we desire it. And then we minify it, and then we basically stick it in a style tag in your DOM. And this gives us the best of both worlds, right? Our designers can go and they can make a CSS file for that one component, and they can make it live with that component. And they can write whatever CSS they want, and it will never affect another component. But to them, it's as if they're just doing CSS the way they've always done it. And the other nice thing about this is our designers can go in the components folder, and it's basically a living style guide for them, right? So they can just have another piece of code that just imports all that stuff, and it's the project style guide, it's the branding stuff. So it's really exciting. And the other quirk I want to talk about rather is this end-to-end testing framework we're using. It's not a JavaScript framework. It's a Python framework. Why did we do that? Well, it turns out that you don't need to actually write any Python. It's called Robot Framework. It allows our QA team to write tests in something that's very similar to sort of natural language. And it's very easy for them to work with, and we figured out how to hook it into CI, and so, why not, right? I can actually show you an example of what some of those tests look like. So we have an automated test that, checks that you can log in, basically. And, our quality assurance people, some of whom are great with JavaScript, some of whom are not great with JavaScript, they can all do this, and that means that they can contribute much more fully to our cross-functional teams. We've considered switching over to Cucumber.js, which gives you a similar thing in the future, but I'm still sort of evaluating it. And so then quirk number 3, we have the main React starter, which is ES6 Babel, as you'd expect, but we, went out on a limb and decided to try something a little bit unorthodox, and we made a version of it in TypeScript, which you can use. There's some nice things about it. It gives you a cleaner sort of prop types syntax. In React, the basic prop types are only checked at runtime. But with TypeScript, you can actually basically give your components, you parameterize them according to an interface. And it will actually check that you have the right types in there at compile time. Checking things sooner is always better. It's always cheaper to fix things. There's a potential, I think, for a cleaner component syntax. You can use it to replace a lot of the sort of default prop type stuff that I actually find a little bit ugly in React. So, it's not a totally crazy idea. It's growing on me. But there's some annoying things about TypeScript and the React ecosystem. Redux only just released official typings for the library. A lot of the other ones like Redux Thunk and Redux Logger that you can use, Radium, they don't have any typings at all. So that's been a little bit frustrating. And code coverage with TypeScript is still something we haven't quite figured out. So if anybody has any ideas, I'm totally open to hear them. So yeah, in conclusion, that's how we do React at Rangle. We've basically put together a standard stack that we keep up to date on a regular basis. We use it as a living best practices guide. We use it as a teaching tool, and we use it as a quick way to get up and running on client projects. And it is open source, and I invite you to go check it out. GitHub/Rangle/Rangle-starter. And yeah, I hope it's useful to you. It's certainly been a good one for us.
All right, so on to business. My talk is titled pretty coolly. Actually, the person who titled the talk is sitting over there. Wave, Adam, wave. Yeah, he's one of our interns. He's leaving pretty soon, so let's say bye. Bye, Adam. We're going to miss you. Please come back. He had this idea for a talk, and I kind of took it and ran with it, and it's a really interesting idea. And the idea is essentially we have a very new and interesting web. It's very data-driven. It's very interesting in how it's handling the data flow of our applications. The whole, I don't know if you've heard of the term unidirectional data flow. I'll go over it in a second. With all this information and all the frameworks that are coming out, like React or React Native, are there things we can look at differently when it comes to styles? And I'm going to explore one of these concepts. I'm going to just kind of experiment and show you what I've come up with, and hopefully get some feedback, and you guys can tell me what you think. So what am I even talking about? There's a term, component-based architecture, and it's sweeping the web dev world. You see it everywhere. I mean, Angular to React, Aurelia, Polymer. I'm probably missing like more like frameworks that are kind of just going down this path of component-based architecture. Component-based architecture isn't a new thing. Of course, it's been around for a long time, but it's something that's kind of new to the web, at least. Especially with the whole, what's it called, web component spec that's been recently released. You're seeing more and more of these frameworks. This is changing a lot of how we're doing stuff, especially when it comes to styling, and I'll go into that a little bit more. But first, let me talk about some of the frameworks I'll be talking about. So there's Redux. So it's a popular library. It's used heavily by React, and it's essentially a way to handle your application state, unidirectional flow, top-down, immutable states, and it's a really interesting approach that people are kind of afraid of, but now they kind of embrace wholly. And then you have something called React Native. While we might know about React, React Native is kind of very new, and the idea essentially is that it's not a hybrid system. Like, I don't know if you guys have heard of Cordova or PhoneGap, and there are libraries based off of that, like Ionic, which is using Angular. It's not that at all. It's an actual native implementation that you kind of transpile from React to native. And it's a completely different system in place, and it gives you different opportunities, but also different challenges. So I'm going to go over one of those challenges, actually, later on. So a quick introduction is that it's, React, if you guys don't know what it is, and I think who here has used React? Let's raise our hands. So just over half of us. For those who don't know, and who are curious, React is a component-based library by Facebook. It's a solution they created for their own application, Facebook. If you go online, you look at their code, you'll see it's actually a React application under the hood. It's really cool. It took the web by storm last year. I think it came out 2013, but since then it's become very, very popular. It focuses on the UI layer, and it does something cool called the virtual DOM. It creates a virtual DOM so that you don't have to worry about diffing objects. I won't go into it. It's kind of technical. It's kind of boring. But these are the key points, especially the whole the JSX templating. These things kind of make React different. And when you combine these things together, you kind of create a very interesting component-based architecture system that people have really taken to. So quick little example of what it looks like for those, who don't know. You can just see a little example of a hello world message. You're creating a little class over there. You have a render function on that class object. You render, literally, it looks like just pure HTML. And you have access to something called props. And you can see that there's a prop on the rendered object called name. So this props.name is going to equal to John. So you'll see a little component that says hello John when you mount it on the mount node, which is going to be the home node. I mean, this is not really a React tutorial. I just wanted to make sure we kind of know what it looks like. This is React. This is a simple React component. And this is kind of the basis of all React applications. So how does Redux work? So Redux is not so much about React. You can use it in other frameworks and applications. We actually use it internally on Angular 2 and Angular 1. And it's a really interesting concept. There's this idea that we've talked about a lot on the web, and especially in the past, called the global state. Global state's a scary idea. Like, you have this giant object somewhere sitting, at the very top of your application that has all its information. Why this is scary is manyfold. I mean, you kind of have a lot of weird things happening when you don't really know where it's coming from. Or even if you do know where it's coming from, you don't know how to handle or deal with it. You can't partition things out very easily. You can't componentize. You can't create isolated ideas and concepts. And this is a complicated and problematic thing. And people have kind of been avoiding it for a while. But we've kind of realized recently that the issue isn't so much that the state was global, but the state was mutable. When something is mutable, if you don't know what mutable is, it means that you can change an object, its reference. So let's say you have an object that has 4 keys, foo, bar, x, and y, and you change the value of x. You have later on in the application, the value can be something completely different, and you have no idea how that happened. It's like, how did that happen? What made x equal 10 instead of 5? And this whole mutable nature is a completely scary and terrifying thing people have been trying to avoid for a very long time. So there's a library called immutable.js, and there's other immutable libraries out there. But the core concept is also just baked into JavaScript as well. Object.freeze, for example, will make objects unchangeable. When something is immutable, it means that you can't actually change its values. You have to make a new object, reference the old object, and change the values on that new object. By doing this, you never, ever, ever have to worry about an object not being what you expect it to be, because you can follow a path of how your object turned into what it was. You can say, oh, I did this action, and then it turned to this object, and I did this other action, and it turned to this object. That's the kind of basis of Redux. You can see over here, a little diagram, maybe a little bit confusing, but it's pretty simple, that you have access to actions and little slices of the global state in a component. So this action would trigger an event. Maybe you click on a button, and you add a number to another number. You add 5 to 2 or whatever it may be. This goes up to the global state, and this is then reduced and sliced down back into the view as this new number. It sounds pretty complicated, and I don't know if you guys are very familiar with it. I'm not going to go over the details and tutorials of Redux. There's some better ones out there than I can describe. But the core idea essentially is that you have a global location for all of your data, and that you can change it with actions. And this is a very specific way to handle data flow, and you don't have to worry about things changing without expecting it to, because you know exactly what happens. Redux, you can even, with the right libraries and tools and middleware, you can rewind the process very easily and see how you got to where you got. So it's a very powerful thing. It's a very cool thing. And it provides a lot of interesting opportunities for creating a very predictable, I think that's a big word to use, predictable data flow and a nice and solid architecture for your applications. So what's the problem? So it sounds great. Everything sounds awesome. Where's the beef? So there's not necessarily any problem. I like to think of it more as opportunities. So there are certain challenges we have to come across, like circumvent or surmount in the web world, and some of them are made more apparent in certain frameworks. And we're looking at Redux as an opportunity to kind of handle those challenges. So here's some basic ideas and challenges that we've kind of tried to talk about. We want our components now to be so isolated from each other that they could be plunked anywhere in an application or anywhere in another application and still work. They want to be so, the term I think we use is either dumb or, what's the term I'm thinking about? Stateless, yeah. To kind of give you a component that can be simple and easy to use and not break and not have all this additional testing you have to apply to it. It really makes them really nice. You still have your smart components, which are like they're parents of these components that pass data down, But the done components can do whatever the heck they want. They can go wherever you want, and you can just pass the right data to them. They can output the right data, and things are simple. This adds some complexity because the relationship between style and state is important. If these components are very, very dumb to the point that they don't even store any local state, then certain visual and stylistic ideas we have become challenging, like buttons that are visually disabled. If they don't know that they have a local state that says disabled, then how do they disable themselves? Maybe items in a list that are selected or clicked on. If they don't know that there's no property to that component that says I am clicked on or I am selected, then how is it supposed to know it's selected? So if you output and you extract all this data and all this local state from a component, where do you put it? There are a lot of people out there who think that it's fine to have some local state in components. Some who think there's no need or no reason to have any local state in components. I'm not even making a prescriptive like idea here. I'm saying that you guys can come to your own conclusions, decisions on this. But I have some fun little demos. One really that I kind of show a way in which you can extract almost all local state from a component, put it into an immutable global state with Redux, and have this component be super duper dumb. This is really kind of another product of unidirectional data flow, which is, I said I'd go through earlier. And what this means is that you have a tree hierarchy for all your applications. You have this global state at the very top, and this global state can change because of an action. And then this action change kind of feeds down this tree where you see all these subcomponents that are dumb, ideally, changing. Maybe this tree changes some properties, and this one is listening for one of them. When it's true, it gets blue. When it's false, it gets red. And there's 20 of these components, and they have children that listen to some properties, and they have children that listen to properties. And so whenever you change that global state, you have this kind of chain reaction that changes the entire application. This is very valuable because eventually you can create a serialized state, if you wanted to, plunk it into your application, say, here's a state I downloaded off the internet even, and I'm putting it into my application. Suddenly the application looks exactly the way you expect it to. Everything's lit up, everything's disabled or enabled, colors are red or blue, whatever they're supposed to be, depending on the data that's passed down. It's a very powerful concept, also a very scary concept at first. We're kind of very used to having this local state stored internally in the components. So we click on a button, and we're going to have something inside that button, let's say the components, that says, I'm clicked, and then it just remembers that. This, although simple, causes trouble when you have unidirectional data flow, when you have a singular store that's supposed to store all your application state. We've made this distinction before between application state and visual state. Let's see if we can take that away. So this is one of the big reasons why this is a problem. React Native doesn't do CSS. Well, I mean, okay, it sort of doesn't do CSS. So the problem here is that React Native is native. It's really, truly native in that it's making components that are native to Angular or iOS. It's not making, if you're used to hybrid applications, a web view components. It's not making a div that looks like a button that you might see natively, or a span, or a paragraph tag. These are literally elements that you would see inside of iOS or Android. And these things can't be styled with CSS. There is no CSS like plugin for Android or iOS that I know of, at least. They have to be styled through their traditional styling means. So this is trouble because on the web, we don't use XML for components like they do in Android. We don't use string styles or whatever they use as well. Actually, I'm not sure even. We use CSS. So what Facebook did here is kind of a happy medium. They created a system in which you can create an object that looks like a style sheet object almost, where you have certain props on there that have styles on them. You can pass down into a component and style it that way. Not all of these props and styles will be available. Let's actually go through here. In React Native, like you won't see, for example, z-index, for example, in any React Native component that I know of. That's something that's never going to be there probably. But some basic ones like background color, width, height, border width, border color are available in quite a few components. This is a quick little example of what it looks like. You can see over here, I make a styles object using the style sheet.create method. You pass in an object, and those objects have properties, and those are kind of analogous to a class. So you can have a class that has many different properties inside of them, width, height, background color, what do you want to do if it's active, etc. And then you just pass it into a component like so. So you have a style property, pass in the background property of that styles object, and that would actually translate into what you would expect to see in a style for a component. And this view component is a native view component in iOS or Android. There's ones for text, there's one for a whole bunch of different components that you see only native in those libraries, or rather in those devices and those operating systems. So it kind of works. It's not smooth, it's not what you might expect, but it works good enough. If you really want to use CSS, by the way, you can use this cool little library. It's called React Native CSS. I found it when I was doing research for this talk, actually. It's pretty cool. But it's not really using CSS. What it's doing really is doing the same thing as this. Oh. As this. It's creating you a style sheet with .create even, and it's just exporting it in a JavaScript file that you automatically apply to components if you want to. It's just a nice little abstraction, so you can keep a CSS file in your code base. But the reality is it just turns into what you would expect, an object with those properties that you then pass down. So with that in mind, what are the other caveats? So like I mentioned before, not all CSS styles are available. Z-index is one of them, but there's a ton that aren't available. And styles need to be defined via camel case, something that people aren't really used to. Background color turns into background color with a capital C. Not all components have access to the same styles as well. That's going to be a really jarring experience when you have 2 or 3 different components and you want to, say, give them all, I don't know, a border. But border isn't available in all these components because they might not have borders in their native counterparts. So that's a bit of a jarring experience that people aren't quite used to. And community-created components may not take styles. So, or the styles might be unexpected. So there's a lot of community-created components that map to either custom native components or other native components that aren't covered by React Native. A lot of them are cool. They do great things rather, but they don't all have styles, and that's a problematic thing. I'm just talking about this stuff really to give you an idea of how difficult it is to do styles in React Native. It's not impossible. It's not even like that hard. I mean, often the styling comes for free because, thematically speaking, iOS has a certain structure and idea for what you should style your components as, so they kind of just are in there. But if you want to do some customized styles, it can be frustrating. And you might be asking, okay, so where does Redux come in? I saw how it worked. I can make a component, create a class, and just pass that into my components. It's an interesting idea. So this is a reducer. If you don't know what reducers are, don't think about it too much. I'll go over a really basic idea what's happening here. So with reducers, you have an initial state. In this case, I'm creating an initial state that is a map object. This is usually mutable.js. It has a property called button. It also has a map on that, and the button has all the styles you expect: width, height, padding, background color, what have you. And these are styles for a button, essentially. In the actual reducer function, this is the confusing thing. There's 2 cases. If I increment the button, I want to change the background color to green. If I decrement the function, decrement or decrement? Decrement, thank you. Decrement with this function, with an action rather, I want to turn it to red. So what would happen is that you would get a new object that would, a new map object rather, that would have these different styles. So in the actual component, let's say you have this over here. You see you have a text component. You have a touchable opacity component. Like this is a literal map component that maps to something you'd see in iOS and Android. And on press, you can increment or decrement. These are a plus and minus button. Another counter example. You have a style. And in here, what I'm doing is I'm just passing in from the global state that counter style object I created. I'm doing a 2JS because it doesn't work with immutable objects. You have to turn it into a JavaScript object. And I'm passing in the style sheet button, and I'm creating that. And it actually works pretty well. I'll show you a little example while I'm at it of it working on Android. Little emulator here. And you can see I have my up and down buttons. So what I've done is I want to basically find a way to say, whenever I click a button, I want to know what the last thing I clicked was. Was it an increment or a decrement? So if I click up, it should turn green, and it does. If I click down, it turns red. Very straightforward. Very simple example. And I might even share this code base with you guys later if you want. Let's get back to presenting. So that was very painless. I mean, well, it was painful to figure out and to get to, but when I actually implemented it, it worked really well. And I'm using stylesheet.create internally in the actual components. I wouldn't want to do that. I'd probably abstract this out into a special function that returns exactly what I wanted to return. But I want to be explicit so you'd understand what was happening. So I'm still creating a stylesheet object that needs to be passed into a component, and I'm still accessing the button property on that object. I'm just keeping the entire object definition external to my components. That's being passed down in its props, and those props are in the reducer. So what this means, essentially, is that I now have a reducer, one for storing my, two reducers, actually, for this component button, one for storing my state. So when I click on a button, I want to increment or decrement, and I want to store that number, and one for catching my action and changing my style. So when I increment, I want to change the button styles to green, decrement down to red. This is a pretty interesting thing I did, and it was a really cool little fun experiment. And I'm managing what would normally be handled in local state externally, something that people have a lot of trouble with, and it's very difficult often. I created this concept of a logic reducer versus a style reducer. I don't know if anybody else is doing this, so I don't know what other words to use, but this is kind of what I'm making. And I'm storing my styles in an immutable object. And I'll get to why this is interesting later. Who here has used immutable.js? Few people, so I'll go over a bit in advance. Sorry, before I talk about this, what that is and what it does. So we might want to ask, what else can we do with this? I mean, often we have challenges that turn into opportunities. So this challenge was a challenge that had to do with a lack of CSS. But now that I know I have to use JavaScript essentially to handle my styles, what can I take from this? What can I, how can I pivot and turn this into a really cool opportunity? So consider a functionally composable style. Imagine you had an object that you can return. I have functions over here, a button object that's returned, a round component object, an accent style object, and an elevated object. You have these functions that you pass through, and then you compose them into a button that's round and has an accent style. Maybe it's a faint blue or whatever you want to have, and that's elevated. You basically have created components composed strictly from your JavaScript functionality. If you're a functional programmer, if you like FRP, this can be very appealing. There's a lot of interesting things you can do with that, and I've only just touched the surface of that one idea, but the idea of functionally approaching your style sheets isn't new. There's lots of JavaScript-oriented style libraries out there, but this is one where you kind of have to do it. So what can you do with that? What can you take away from that? And we can take a look at immutable.js as well. So immutable.js, just to take a step back and explain real quick, it's a library also by, I think it's by Facebook, right? People? Seth? Yes, Facebook. So this library is a way to create components, again, that cannot be modified. This is back to that whole reducer idea where you can't modify the global state. You can only make a new copy of the global state. Immutable.js, same idea. Let's say you want to make an object, and you never want to be able to change any of its properties. You'll want to maybe modify it or create a new one, but that original object, that original variable you created, or that constant you created, cannot be touched. Immutable.js is really, really good for that. So there's a particular kind of object. There's different ones. There's lists, there's maps, there's also records. And a record's a kind of object that's very interesting, where you can, for example, give it a bunch of default like properties. You can say, give it 5 properties: height, width, border, background color, and let's say font size. And these are default properties, and you can give them default like values as well. If you were to change any of these properties by making a new version of itself, like say, clone that original reducer, that original record and make a new one, that's great, that's awesome. But if you were to delete any of these properties, so let's say you had it green for some reason, and you said, you know what, I don't want it to be green anymore, I want it to fade away, I want to remove the green after a minute, it immediately go back to its default color. So this is a really interesting idea because you're creating an object that has default states, and these default states can be styled states. And if you have an interface, it's kind of like an interface. If you have an interface for an object, because you can't actually add any other properties and you can't remove any properties from this object, it has to be that way, you can do some pretty interesting, almost tests around your styles. You can do some really interesting default expectations around your styles and default styles in general for your entire application. It's, again, things I've just touched on and explored, but it's, again, trying to pivot your challenge into an opportunity. So is this just restricted to React and React Native? No. So if you people know what Angular 2 looks like, I'm making a little counter component here. There's a property called NGStyle. So the NGStyle property expects an object that has to map down into, a key value pair for styles. So this is an example of a quick object where you have properties assigned. And imagine instead if you had a reducer that passes down something called a counter-style object that you just did a 2JS on, give you an actual object, you would have the same functionality essentially. And the additional value is that if you want to do this on an Angular 2 application, you would have access to the full suite of CSS styles that you would normally have. You wouldn't have to worry about just having React Native components. And this is, again, probably where the composable nature of style sheets comes into play. So you don't have to do it just with React Native or even React. This concept is kind of external to this. It's, again, more focused on this idea of a unidirectional flow, immutable data store, which is your global states, and handling the challenges of having, Seth mentioned this in his talk a little bit, scope styles. There's a lot of different ways to handle this. I mean, people want to do scope styles with inline styles, and this is kind of the same thing. But imagine if you had scope styles that you functionally created. This could be a very powerful idea for a lot of people. So should I start doing this now is a question you might be asking yourselves. I actually have no idea. If you're the kind of person who likes to play around with these ideas and try things out, and if you're really, really curious, this would be a lot of fun to play with. I really recommend trying it out. That being said, the answer is probably maybe sometimes. So with React Native, it's probably a very good idea to do something like this, especially if you are adverse to having local states in your components. This is a good solution to that. You can externalize all your states and put it into a reducer and handle it all externally. And that could be a very powerful thing, like I mentioned before. But if you're working with teams of designers, this can be very difficult. I know rating was mentioned earlier because our designers locally weren't a big fan of that. This is the same vein. You're actually doing an immutable object style that you might functionally be composing. That's a lot for a designer to be taking in, who may be amazing at CSS and visual design and graphic design, but maybe has no JavaScript background. So if that's the case, you might want to consider something else. And I can't even really decide if this is adding more business logic or moving what I never considered as business logic to something that absolutely is. I mean, this is something I didn't think about until I really worked with this. I mean, I never really thought about styles and the even conditional style application as a business logic thing, but I guess it is because you have it all based off of user interaction, and you have it all based off of data states. So this is making it very explicit. Literally, this is going to be in your global state. It's going to be functionally handled. It's going to be JavaScript handled. And if that's not something you're comfortable with, if you want to keep CSS styles separate from your global state, then this is something you want to do, I think, external to React Native, only for fun. Don't do it on a real project. But with React Native, if your designer is comfortable with it, or if you're the designer, it's probably a really cool idea, and maybe even be a very good one. That's it. Thanks for listening.